Hi, I am Dr. K. Kannan from Hindustan College of Engineering and Technology. In this video, I am going to discuss the construction of analytic functions by using Miline Thomson's method and its applications. Generally, the analytic functions can be represented by f of z is equal to u plus iv. Here, z is a complex variable. Will be take z is equal to x plus iy, and u and v are the real and imaginary part of f of z, which contains in terms of x and y. By Miline Thomson's method, there are two cases arise. First case is if given the real functions of analytic function, that is u of x comma y is given, by the Miline Thomson's method defined by f of z is equal to integral dou u by dou x of z comma 0 into dz minus I into integral dou u by dou y of z comma 0 into dz. Similarly, the imaginary functions of analytic function is given, that is u of x comma y is given, f of z is defined by integral dou v by dou y of z comma 0 into dz plus I into integral dou v by dou x of z comma 0 into dz. For example, find the analytic function f of z whose real part is u is equal to x cube minus 3xy square plus 3x square minus 3y square plus 1. By the Miline Thomson's method, we know that f of z equal to integral ux of z comma 0 dz minus I into integral uy of z comma 0 into dz. By using the given function u to find out the first order partial derivatives, dou u by dou x is equal to 3x square minus 3y square plus 6x. After finding dou u by dou x, we replace x by z and y by 0. So, dou u by dou x of z comma 0 equal to 3z square plus 6z. Similarly, dou u by dou y equal to minus 6xy minus 6y. We replace x by z, y by 0. Dou u by dou y of z comma 0 equal to 0. Now, we will be substitute in Miline Thomson's formula f of z equal to integral 3z square plus 6z into dz minus I into 0. Now we will be integrate, we get f of z is equal to z cube plus 3z square plus c, which is the required analytic functions. Now we will be take another example. Find the analytic function f of z whose imaginary part is given, v is equal to 2xy. By the Miline Thomson's method, we know that f of z is equal to integral dou v by dou y of z comma 0 dz plus I into integral dou v by dou x of z comma 0 into dz. By the given function v to find out the first order partial derivatives. Now we know that v is equal to 2xy. To find dou v by dou x equal to 2y, we replace x by z, y by 0. So, dou v by dou x is equal to 0. Similarly, dou v by dou y equal to 2x. Now, we will be replace x by z, y by 0. Dou v by dou y equal to 2z. We substitute in Miline Thomson's formula f of z is equal to integral 2z dz plus I into 0. Now, we will be integrate, we will be get f of z is equal to z square plus c, which is the required analytic functions. In this Miline Thomson's method, we can use fluid flow. In a fluid dynamics, the complex potential is useful quantity used to analyze certain fluid fields. It can be defined by the analytic function f of z is equal to phi plus I into psi. Here, phi is called the velocity potential, psi is called the stream functions. For example, an incompressible fluid flowing over the xy plane has the velocity potential phi is equal to x square minus y square plus x divided by x square plus y square. Find an stream function psi. We know that Miline Thomson's method f of z is equal to integral dou phi by dou x of z comma 0 dz minus I into integral dou phi of by dou is y of z comma 0 into dz. Now the given function we consider phi is equal to x square minus y square plus x divided by x square plus y square. Now to find out the first order partial derivatives with respect to x and y. So dou phi by dou x is equal to 2x plus y square minus x square divided by x square plus y square whole square. After finding this, we replace x by z, y by 0. We will get 2z minus 1 by z square. Similarly, we find out dou phi by dou y of z comma 0. Now we will be substitute in the Miline Thomson's formula. F of z is equal to integral 2z minus 1 by z square into dz minus I into 0. Now we will be integrate z square plus 1 by z plus c, which is the analytic function. By our required question is we find out stream function. So after finding the analytic function, we replace z is equal to x plus iy. So f of z is equal to x plus iy whole square plus 1 by x plus iy plus c. Now we simplify and will be separate real and imaginary part. Here real function is considered velocity potential and imaginary function is stream function. In our question we given velocity potential. Now the required question is stream function. So the stream function is imaginary part. So psi of x comma y is equal to 2xy minus y divided by x square plus y square plus c, which is the required solutions. Now we will be take another example. In a two-dimensional fluid flow, if xy into x square minus y square represent the stream function, find the corresponding velocity function and also find the complex potential. The last question is a given velocity function, we find the stream functions. But here a given stream function we find out velocity. We know that by the Miline Thomson's method, f of z is equal to integral psi y of z comma 0 dz plus I into psi x of z comma 0 into dz. Now we consider the given function is equal to psi. Psi is equal to xy into x square minus y square. Now to find out the first order partial derivatives with respect to x and y. So dou psi by dou x is equal to 3x square y minus y cube. Here we replace x by z, y by 0. We get dou psi by dou x of z comma 0 equal to 0. Similarly, we find out dou psi by dou y equal to x cube minus 3x y square. After finding the first order derivative, we replace x by z, y by 0. We will be get dou psi by dou y of z comma 0 equal to z cube. Now we will be substitute the Miline Thomson's formula. F of z is equal to integral z cube dz plus I into 0. Now we will be integrate. We get f of z is equal to z power 4 by 4 plus c, which is the analytic function. But our required question is we find out the velocity functions. Now here we replace x by z, z equal to x plus iy. Now the f of z is x plus iy whole power 4 divided by 4 plus c. We will be expand and we will be take separate real and imaginary part, and here the real part is considered velocity function. So therefore we get velocity function is psi of x comma y is equal to x square by 4 minus 3x square y square by 2 plus y square by 4 plus c, which is the required velocity functions. Thank you.